Hey Calculus kids, how are you guys doing? Welcome to week 5 Thursday for AP Calculus AP. I hope you guys had a good 3 days of virtual online learning. So today we are going to talk about a few things, but before you do that, go ahead and pause the video and answer the following 3 questions. All right, let's take a look at this question right here. I know it's very tempting to go ahead and once you factor the denominator, to not look at the numerator, but in this situation, I really have to re-emphasize that you need to make sure that whatever you factor from the top and bottom, that you match them. And if there's something that you cancel, like x minus 2, you cancel it so that way you can avoid solving for x and then mistakenly thinking that 2 was going to be a vertical asymptote, which in this case, if you look at the graph, it really is not. So when x equals 2, it is a hole. It's pretty much empty. So in this case, at x equals 2, both the numerator and denominator, both the denominator and the numerator are equal to 0. This, in this situation, is meaningless. This point, there's a hole in the ground. So you just have to be very careful to avoid that. The second method, instead of factoring, is if you go ahead and divide all terms, numerator and denominator, by the highest power. So in this case, it's going to be x squared. So I'm going to divide everything by x squared. Here you have an x over x squared. So that's an x and an x. So then one of the x's cancel, and you have a 1 over x. Well, it's assumed that as x approaches infinity, you have 1 over infinity. And when you have a very small number divided by a very, very big number, it is eventually going to be approaching 0. So I'm going to cross it out and put 0. And that's where that comes from. You do the same thing over here with a negative 2 over x squared. You have a 0. On the denominator, x squared cancels. You resulted with a 1. Same thing with the middle, 0, 0. So ultimately, you're going to have a 0 over 1, which is just 0. And this is for the horizontal asymptote. And there you have it. Your vertical asymptote from before when you factored out the denominator is 3. And your vertical asymptote is 0. I'm sorry, vertical asymptote is 3, and your horizontal asymptote is 0. If you're looking at this from a standpoint of a chart, this is what you will have. So as x approaches 3, if you plug into the chart, you can see that your y value gets bigger and bigger, even though your x value, you're just only going up by like a tenth of what it should be. It is going to be getting exceedingly larger and larger for the y value. So you can just say as x is approaching to 3, in my case from the right side, your limit is going to be going to positive infinity. And as such, when your limit x is approaching 3 from the left side, your limit is going to be negative infinity. And if you did a chart with, let's say, 2.9, 2.999, it will give you a very big negative number, probably negative 10,000. And lastly, now when I said find the horizontal asymptote, I gave you guys the 3 rules. You should know what they are. That's great if you have the exponent pretty clear to see. Well, in this case, this is a little bit more convoluted. The numerator, your exponent is x to the 2/3. The denominator, it's a little bit more obscure. You have a cube root of 5x squared. So what you should do is you don't need to worry about the 5. You can just go ahead and cross it out and pretend it's not there. Because what we're really focused on is what is the power in exponential form of this radical form. From algebra 2, you know that this is going to be the power, this is going to be the exponent, and if you're converting from radical to exponential form, it's always x power over exponent. So in this case, it's x to the 2/3. Well, great, because they have the same power, which means you will have to look at the leading coefficient. Well, in the numerator, you have a -4. In the denominator, you have a cube root of 5. So this is going to be your answer, and you can go ahead and basically divide it using your calculator to get to the answer of what your horizontal asymptote is going to be. So at this point, you should have gone over how to find the vertical horizontal asymptote, going over the different examples of doing that. If you've been missing a few of the classes, this is week 5, Thursday. Your videos of all the classes that if you have been missing since week 1, Monday, to week 5, Wednesday, is on my YouTube channel. So make sure you guys are catching up with that. So let's go ahead and take a look at what we're going to be focusing on today. All right, so we're kind of approaching the end of Unit 1 on limits. Unit 2 is going to focus on derivatives. And Unit 3, which will take us all the way to December, is going to focus on application of derivatives. So calculus is very much like building a house. Limits is kind of the concrete foundation. Unit 2 on derivative is your walls. And Unit 3, application of derivative, is your roof. So if your walls and your concrete foundation on limits and derivatives are shaky, your roof is not going to sustain itself. So it's really important that you keep up with the pacing of this class. And I know it's extremely difficult with this unique situation of the virus going around, and then also the smoke, which we're having virtual days. But please do take the time to go over the videos, look at your guided notes, review those steps and those additional practice problems, because I'm spending a lot of time making these videos, hoping that it will in some way help, even though I'm not seeing you face to face. All right, so now that we're done with, almost done with the review with limits, I want to go over a few of the reviews that I have optioned here for you guys. First one is a concept sheet, which is going to be right here on this link, and you can go ahead and just type this in. Or if you want, you can go to the Google Doc for this class specifically for calculus, scroll down to the bottom of Unit 1, and I'll have this linked already. So you can just click on the hyperlink and it'll take you there. But if you don't want to do that, just make sure you do the capital Y, capital Z, capital T, capital C, because capitalization does matter. I also have a limit, or Unit 1 limit exam review right here. And then this right here is the Google Doc for all of your skills. So even if you would like to actually move ahead and see what derivatives are, go to this link and you're welcome to do that. All right, so we're going to go ahead and get started with this today. Let's go ahead and take a look at your guided notes. So turn over to week 5, Thursday. You do have a calculus puzzle that's going to answer the question, name the nastiest theorem in mathematics. Then I have the questionnaire that's going to be on limits that we're going to go over. And then a few practice problems from the textbook on finding vertical asymptotes, and then also discussing the discontinuity. This is a review of Unit 1. First one is actually finding the limits when given the diagram. The second one is I will give you the limits and then you go backwards and you draw the picture for me. And then we're going to go over these 3 questions right here. And then also additionally these 3 questions right here. All right, so with that said, let's start off with the questionnaires. It's essentially a review of everything that we discuss in Unit 1. So go ahead and turn over to this page. This is where your questions are. Pause the video, go ahead and answer them. Okay, let's go ahead and go over them. What is a limit? It's basically the value as you're approaching a number from both sides, and both sides meaning that you're approaching from the left side and the right side. In this case, it is 2. What is the difference between numerical, graphical, and analytical limits? Well, these are the 3 different methods of finding limits. One with a chart, another with a graph, but you have to have a graphing device like Desmos or TI-84. And then analytically means that you are using algebra to cancel. And the 2 strategies we went over are conjugates and factoring. And factoring, you could do factoring trinomials with a power of 2, or you could do factoring with binomials with cube factorization. What are the 3 limits that fail to exist? These are the 3 that we went over in this unit. One is different behavior from left to right. As you're approaching the left, you go down to a negative number. As you approach from the right, you're going to a positive number. Unbounded, which is involving vertical and horizontal asymptotes. As x approaches this number, let's say it's at 2. As x approaches 2 from the left side, your y value is going to positive infinity. As x approaches 2 from the right side, your y value is going to negative infinity. So it's unbounded. Next one is oscillating. This obviously involves trig function. So as you're getting closer and closer to 0, for example, if I say negative 0.01, your answer is a positive. If I say negative 0.001, your answer all of a sudden dips onto the negative. So it's just oscillating up and down. 2 strategies of finding limits: analytically, conjugates, and factoring. The 2 different special trig limits that we went over are these ones right here. And there was a video guided notes that we went over with, I think, earlier this week, probably week 5 Monday or week 5 Tuesday was one of the 2. So if you did not watch that video and you have not been keeping up with your guided notes in your note packets, make sure you go back to that. 3 different factors that causes discontinuity. The first one is if x approaches c on the left side, the limit doesn't exist, or if f of c is undefined. And the next one is when x equals a specific number, the y values does not match. So these are the diagrams that you can see for those. Number 7, what is the difference between open and closed intervals? Well, this is what it looks like. Open intervals, you generally have parentheses. A and B are not included. All the values in between A and B are. With closed, it is brackets because all the values, including A and B, are included. And this is, I asked this question because it's a good segue for the mean value theorem that we're going to talk about coming up. What is the difference between a removable and non-removable discontinuity? This is a removable discontinuity, and this is a non-removable discontinuity. One-sided limit is just as x approaches a number from the left side, or it could be from the right side. How do you know if the limit exists? Well, you obviously want to make sure that as x approaches a number on the left side, the y value of that left side number matches the y value of the right side number. Infinite limit is when you look at the vertical and horizontal asymptote, it's a limit that goes without bound. And how do you know if there is a vertical asymptote? Well, you want to make sure you factor the numerator and denominator, cancel whatever is cancelable, and then you basically set the denominator to 0 and solve for x. All right, you guys, let's go ahead and take a look at this page right here. You can go ahead and do the following over here at your own time and own pace, that's fine. So make sure you guys kind of move your paper, like rotate it, and then go ahead and do these 3 questions. Here are the answers for those questions for the limits. These limits are a little bit more complicated. Okay, so let's take a look at the first one, or the second one in the middle. First strategy is by a conjugate. You know that as you'd use direct substitution, you're going to have 2 times 0, which is going to be 0. That's going to be undefined. So the conjugate of this is going to be square root of x plus 16 plus 4. And you're going to do that top and bottom. And of course, you will have the FOIL. So as you go ahead and FOIL the numerator, you know that first is going to be square root of x plus 16 times the square root of x plus 16. Square root cancels, so you have x plus 16 by itself. Then you know that the outer is going to be a positive, the inner is going to be a negative. They both cancel because all the terms are the same. Then last is going to be a negative 4 times a 4, which is a negative 16. And great, lucky for you, these two numbers cancels. So all you have left is just an x in the numerator. Now the denominator, you don't want to FOIL this because you can directly cancel the x in the numerator with the x in the denominator. This x was what really was kind of messing you up. So then you have a 2 left with the square root of x plus 16 plus 4. Now I can plug in the 0 for the limit. 0 plus 16 is 16. Square root of 16 is going to be a 4. 4 plus 4 is an 8. 8 times 2 is a 16. So 1 over 16 is your answer. All right, let's take a look at the first one over here. Now with this one, you have literally a fraction minus a fraction on top of a fraction. So you want to go ahead and make sure you can combine these two fractions together. The common denominator is going to be 2 times x minus 1. So going back to third grade, for the 3, you multiply by x minus 1 top and bottom. With the second fraction here, you're going to multiply 2 top and bottom. So then if you distribute 3 times x is 3x, 3 times negative 1 is a negative 3, and then 3 times 2 is going to give me a 6. This is where I'm at right there. And then from there, you can go ahead and factor the denominator as well. So the way you can factor this is you're going to ask yourself, what times what gives me 2x squared? I can say 2x and x. What times what gives me a negative 3, which is the last number? I can say 1 and negative 3. And then when I cross multiply this, 2x times 3 is a negative 6x. X times 1 is a positive 1x. When I add it together, it's going to give me the middle number of negative 5x. So when I factor this, it's 2x plus 1, first binomial, x minus 3, second binomial. Okay, so then looking at this right here, you have 3x minus 3 minus 6, which essentially is 3x minus 9. Now, this is still your numerator. What can I factor out from here? I can take out a 3, which will result with the x minus 3 in parentheses. And you also have this part as your denominator, but remember there's a division sign, so I don't want the division sign. I'm going to change that to a multiplication sign. So you multiply by 1 over this thing on the bottom, and lucky for you, they do cancel. So you have a 3 times 1, which is a 3, and then this part right here in the denominator. Now you can use the limit as x approaches 3, even though I did not do initially, but I knew it was result in undefined. Now you can plug the 3 in. 3 minus 1 is a 2, 2 times 2 is a 4. 3 times 2 is a 6, 6 plus 1 is a 7, so 4 times 7 is 28. On the denominator, 3 stays on top. All right, you guys, so we pretty much kind of went over a summary of Unit 1. We went over the summary of Unit 1 using words and concept memorization, in addition to practicing with a few examples. I would like you guys to go ahead and maybe start off with some of these ones right here. These are somewhat easier. Pause the video. Here are the answers for that. And notice the strategy with this is that, unfortunately, you cannot factor anything. You can't use analytical algebra to do this. So in which case, the only way that you can do this is either by graphing and then visually looking at the graph, or you could do a table like what I did here. And you will have these questions mixed up with some of the analytical questions like we just saw, with the conjugate and also the factoring on your AP exam. And it's really up to you to figure out which one is a strategy you're going to use to find the limit or the answer to the limit. All right, if we're done with that, let's go on to the calculus puzzle, and you can go ahead and work on this. All right, you guys, I hope you have a wonderful day. I will see you guys soon. Take care.